Okay, we're unmuted at the desk. HDR is rolling. Live stream is on. Okay. Oh, again, I'm just gonna do that. Maybe Damon's gonna do it. Thank you, Damon. Hello, everyone. Welcome to Concordia University's Force-Space. Thank you for joining us for today's event, LIEN-D's Mini-Symposium, LIEN-D. And to help situate you, we are streaming to YouTube live from Force-Space, which is located in unceded Indigenous lands in Chichage, Montreal. Force-Space, we work with the entire university community to mobilize knowledge, co-creating daily activities, examining research questions, and on projects that are in development here at the university. And today we're running this event as a hybrid Zoom meeting. So we welcome any comments or questions that are there through the chat or a raised hand. You can also camera on and say them on the microphones during the Q&A. But for those of you in the space, if you'd like to participate, just let us know. Raising your hand will get one of our microphones to you. And with that, it's now very much my pleasure to hand it over to Damon Matthews, Director of the LEADS program, and also Professor in Concordia Research Chair in Climate Science, Sustainability, Geography, Planning, and the Environment. Damon, over to you.
Thank you, Doug. Welcome, everybody. Thank you for coming today. This is the beginning of the 4th year of our LEADS program. So thank you to those of you who have been in the program for a little while now and are here to share some of your work. Welcome to the new students who are here for the first time. I'm going to introduce the program to those of you who reintroduce it to those of you who've been here before. I won't speak for more than 5 or so minutes at the beginning. And then I'm going to pass it to Micheline Ayoub, who is the new Executive Director of Sustainability in the Digital Age at Concordia. She's going to introduce herself and also talk a little bit about SDA and also Future Earth, who are our main partner organizations on this endeavor. On the LEADS project. And then Odile Joblin, who many of you know, at least by email, will facilitate the presentations that everyone has prepared. We'll do 3 rounds of 4 presenters each. One maybe has 5. So these are short 3-minute presentations. We'll go through all 4 presentations and then we'll have questions for the panel as a whole. After that, we'll have a short break. We're going to do a little bit of a get to know you exercise so that people can get a sense of who's in the room. And then there will be a lunch available at the end. So that is the progression of today. Thanks again for being here. So some of you know already what the LEADS program is. For those of you who don't, this is an NSERC Create funded graduate training program led by Concordia, operated jointly across the 4 universities in Montreal. And I believe we have representatives here from all 4 universities, which is great. The central premise of the LEADS program, it's a very diverse group of actual research projects, as you will hear over the course of the morning. One of the central premises is this idea of 2 primary forces that are shaping the world. One of them is global environmental change, climate, and other forces leading to substantial environmental changes around the world. And the other is the digital revolution, which is really reshaping how we do everything in the world. And one of the ideas of this program is to think about ways that these 2 things can be brought together and that we can leverage the power of digital tech and the innovation going on in that space to try to shift the world towards more sustainable ways of operating. So this is really framing digitalization and digital developments as potential disruptors and accelerators of the transition to more sustainable ways of life. The goal of the program itself is to develop the skills, knowledge, and experience in sustainability, science, and digital innovation in order to accelerate these transformations. And again, the goal is, we are trying to move towards a more sustainable, equitable global society. We need to use all of the available tools. And one of those tools that many people don't necessarily associate it with sustainability transitions, but is extremely powerful and has the potential to contribute is that of the digital revolution. The actual research themes within the program span a very wide range. When we put together the program, we organized them into these 3 axes, which seem to catch everything. So one is climate mitigation and resilience. Another is systems-based approaches to sustainable development goals, which catches anything from biodiversity loss to energy transitions. And then the third is this idea of enabling the transformative power of sustainability in the digital age. We have a fairly big team. I'm showing here all of the professors at the top who are supervising students in the program. I guess there's about 18 of us now or so, 19. Along the bottom are 4 of the representatives of Future Earth Sustainability in the Digital Age, 3 of whom are here today, I believe. And then over in the right-hand corner, you see Odile, our project coordinator. These are the primary objectives and elements of the program. One is so the 2 kind of biggest pieces of the training. The 3 biggest pieces are, 1, an internship, and so the idea is to take on a small 6-week or so internship at some point during your degree, either with Future Earth STA or with one of the other partner organizations, or with some organization that you identify as being interesting to do this, in order to gain exposure to some new ideas and a little bit of experience outside of the normal scope of your graduate program. Second is the summer school course, which is offered in May. This is a 3-credit graduate course that gets taught as a 2-week intensive at the beginning of May. The third is a leadership training workshop. This will be run in February and is a 2-day workshop where we try to learn about what's called collective leadership, the idea of trying to mobilize expertise and experiences across a diverse range of people towards the goal of sustainability leadership. The fourth is this theme of digital collective intelligence, which we have explored in a couple of different ways over the last few years, and I would say stay tuned for more information about this. There's going to be an activity coming up in the new year oriented around this idea of using digital spaces and digital platforms to access expertise around the world, and taking the collective experience of that towards some goal. We have a regular seminar and workshop series. I'll give you a bit of a schedule for what we have planned for the next few months. And then the last one, which is something that's more encouraged rather than required in the program, is attendance at international science policy meetings. And so if you have an opportunity to go to something that is relevant to this, please let us know, and we will encourage you and try to support you in doing that. Just to give a couple of examples, I'd say the majority of the internships of students so far have been with Future Earth or sustainability in the digital age. And so Micheline will speak a little bit about those organizations and maybe touch on some opportunities there. The other 2 main partner organizations are Uranos and the Transition Accelerator, who are also open to hosting interns. And then I'd say a third or so of participants have actually identified their own internships. And so that is an option as well if there's something that you encounter that you would like to do. We also have a blog on our website. After students complete their internships, we encourage you to write up a little blog post about your experience, and we've posted those on our website, and I've shown 4 examples up here. These are a couple of images from our leadership training workshop last year. This was co-facilitated by myself and Nilufar Sabak Kasuf, who is one of the members of Sustainability in the Digital Age. Last year, we had a bit of an emphasis on storytelling, and we had someone came in and do a podcast exercise in the top right, which students had a lot of fun with. So look out for this. This will be on February 23rd and 22nd, 23rd of next semester, or this coming February. So these are the upcoming events to mark in your calendars. Today's our launch symposium. The next event will be in early November, on the 6th of November. We're going to organize a panel discussion here at ForSpace on the theme of climate finance. And so this will touch on anything from funding climate tech to issues surrounding the insurance industry and climate change, and also things surrounding carbon pricing and potentially carbon offsets. We're still putting together the panel. If anyone has any suggestions for interesting things that we could touch on, let us know. On December 14th in the morning, we're joining force with Future Earth to help launch their 10 new insights in climate science report, which comes out every year. They'll be presented at COP, which is happening right around then. And we're going to hold an event in the JMSP building, I believe, John Molson building, yeah, in the morning of December 14th. I believe there are still a couple of in-person seats left for that event if you would like to come. You're also welcome to attend online. Next year on January 18th, we're going to team up with the Applied AI Institute at Concordia to host an event again in ForSpace, loosely titled at this point, AI Applications and Sustainability. So stay tuned for that. We have the leadership workshop, training workshop planned for February. March and April are still unscheduled at this point, and so there is scope to make suggestions, and we might ask you for some ideas later this morning. And then finally, we have the LIEN-D Summer School, which will be loosely scheduled for early May. The dates aren't 100% set yet. So that's all I have to say for now. We have a website and an Instagram page. Please go ahead and follow if you don't already. And I think with that, I will pass it over to Micheline to say a few words before we go into the presentations.
Good morning, everyone. Can you hear me? Yes, I guess. So I'm pleased to be here. My name is Micheline Ayoub. I'm the Executive Director of Sustainability in the Digital Age and Future Earth Montreal. For those who know, but I will say a few words for those who do not know about Future Earth and sustainability in the digital age. Future Earth is an international network of hundreds of researchers that gathered and around. They used to work together, but then they gathered around the name Future Earth in about 2015. And the executive directorship was here in Montreal. It's made of 9 different hubs. They work together, as I like to say, independently, but interdependently. There are 9 around the world, and we are here in Montreal working on climate change issues and environmental sustainability issues. During that work, we noticed at Future Earth that digitization and digital tools and data are increasing and have become very important towards sustainability. Hence, sustainability in the digital age was formed and became a think tank at Concordia University. We are now part of Concordia. At Sustainability in the Digital Age, of course, we work on anything that is related to sustainability, the intersection of sustainability and digitization, how one can affect or help the other, or perhaps can be deterrent to that. Like, is digitization always good? Or how can it help? And we also work at the intersection of policy and science. We aim to give science advice to policymakers in that field. So we work at the intersection of those two axes, if I can say. One of the major projects we have, or major activities we have, is our participation in a coalition, international coalition. And I'm proud to say I was not, but Sustainability in the Digital Age was a founder of that coalition. It's called the Coalition on Digital Environmental Sustainability Codes, with UNEP, UNDP, the German Environmental Agency, etc. Codes still, like the name says, works on the nexus of sustainability and digitization. And codes, our role in codes is to work on educational topics around that. So we are looking now to do a research project on digital literacy. Our project is wide, but we would be looking, if you're interested, for an intern to help us do a web scraping exercise on digital literacy to bring forward a database on that topic that will help us continue in our project towards that. We are also looking for a intern who would be interested in science communication about sustainability in the digital age. There is nobody behind me. I was looking for Damon. That's all I have to say. If you have any ideas as well for an internship that I did not mention that could fall under our purview or under the topics that we would like to work, come and talk to me or to my colleagues, Jennifer, Andrea, Camilo as well is here. He works with us. Odile also could help, and maybe we can make it work. Thank you.
Hi, everyone. I'm Odile. You may know me from emails. We're going to start with the pitching panel session. So yeah, I'm going to welcome Professor Angela Cross, Professor Jochen Jager, Dr. Camilo Alejo Monroy, and Cristobal Rifo to the table. You can come sit next to me.
Use these handheld microphones.
How are you? How are you doing? Good. How are you? Maybe we can personalize. No, we have it. Only email, only phone.
Okay, so on this table we have Cristobal Rifo, who is achieving an MFA, Master in Fine Arts at Concordia University. We have Professor Angela Cross. She's a professor at Concordia University in the Department of Geography, Environment, and Planning. And she specialized in remote sensing. Then we have Professor Jochen Jager, who just joined the program this year. He's also at Concordia in the Department of Geography, Planning, and Environment, and his specialization is landscape ecology. And then finally, we have Dr. Camilo Alejo Monroy, and he's currently doing his postdoc with Professor Damon Matthews at Concordia University. So how this is going to happen is, how this is going. Hello? So how this is going to happen is each of them will briefly introduce themselves, talk about their research, and then at the end of all the presentations, you'll get to ask some questions to everyone. And eventually we can also take some questions online if we have some. So without further ado, I'll just pass the word to who wants to go first? To Professor Angela Cross.
I thought you would go like this.
Okay. Okay.
Thank you, Adil, for the introduction. If I pass 5 minutes, oh yes, thanks. Just stop me because I have a couple of slides. So the introduction that Adil gave about me is correct. So, so we'll just go on to, what is it? Where do I point? There? Is it? No, that's I can just yes. Thank you. Okay, so I will just jump into my research interests. I work at the intersection of geospatial technologies and environmental sciences. And much of my work focuses on vegetation dynamics. And a lot of my work really involves developing models to relate information about the environment or vegetation characteristics to satellite-derived information. So spectral indices or texture indices derived from satellite data. So I'm using statistical models, but also a lot of the data-driven models, including AI, machine learning. If I can just give you some rapid examples of what I actually do. So these are examples from some of my previous students. I look at, for example, remote sensing of phenology. Phenology is important in terms of if you think about the start in the season, the length of the growing season, the end of the growing season, it is specifically the length of the growing season that has sparked a lot of questions over time. Like as we get warmer climates, as the temperature increases, and the growing seasons get longer, what will be the effects on carbon uptake, because plants are basically active during the growing season. And so this research is looking at the North American tundra, specifically the Canadian tundra, which is very important because it has a lot of the wetlands and peatlands. And the question there is, if it becomes, the growing season becomes longer, will those peatlands that are currently sinks, will they become sources of carbon or not? Or will they just uptake more carbon or not? And this research showed that over 18 years of the study, the start of the season became earlier, the end of the season became later. So the length of the growing season increased by 10 days between 2001 and 2018. And that is in general. But then if you look at the ecoregions, so the yellow outlines there, those are significantly higher than zero. So basically it means that there you had actually a significant increase in the length of the growing season at the southern part of those, the tundra area. So we didn't connect this to carbon yet, but that would be a next step to look at how that affects carbon uptake. Another example would be small scale gold mining. So how, sustainable mining, how does that happen? This is a study area, one of my previous students as well, study area in Suriname, South America, where there is a huge amount of small scale artisanal mining going on, really having, I have 2 minutes, 3 minutes? 2 minutes, okay. And so basically what the student did here, he mapped this mining with, that is in yellow, that is a mine area over 20 years, so 1997, 2009, 2019. You see the yellow area has, 1 second. Has increased around 500% over those 20 years, which is it has a huge impact on the environment, affecting the entire hydrology network with the use of mercury and the exploration of mine. Okay, the next example. So this was this summer, we got approval from the city of Montreal to do measurements, biodiversity measurements in the park. So this was ground measurements with cameras, spectral sensors, and a drone. And we basically, the approval was really to fly the drone actually in this specific area. When we get to my LIEN-D experience, so I entered the program last year. I have participated as a guest lecturer in the LIEND summer course that Damon is giving. I have currently 2 students in the program as well. And I have the SDA there because I'm totally confused about the SDA, Future Earth, and LEEDs and how they connect, because everybody it's in it. So, but we are working with SDA, with Future Earth as well, and with Camilo right now. Jennifer is now working on biodiversity. So there is a project on monitoring biodiversity across Quebec, forest biodiversity. And then Michael is also in this program, is also doing an internship now with Camilo, and he's looking at agriculture monitoring. Okay, I have reached my time, Damon says. Yes, so this is Jennifer from top down. Sorry, Jennifer. Thank you.
Thank you, Angela. I'm going to pass the word to Professor Jochen Jager. If I can just change the slides.
Is this turn? Yeah. Thank you so much for the introduction. Oh yes, this is how it works. So I have been at Concordia for 16 years now. Before worked in Switzerland at the ETH in Zurich, and before I had a postdoctoral research stay at Carleton University in Ottawa. We have three main topics in our lab: road ecology, urban sprawl, and both of them affect landscape connectivity. And we work on several scales, starting with single roads and single cities, and then regions, countries, all of Europe, and one study we've done for the planet. So I've tried to order some of these projects that we have done according to this diagram here. So let's start with some road research on road 175 between Quebec City and Saguenay. We did the field work about road mortality and the use of wildlife passages. More recently, we have started research on A10 between Montreal and Sherbrooke with various student projects. One study now started north of Montreal in the Laurentians with Eco-Corridor Laurentien. And the student who is part of LIED here is Jonathan Wilansky, working on an individual-based model of the fence end effect that is now going on. Several studies on connectivity, particularly about the ecological corridor A2A, Algonquin Adirondacks, another corridor between the Adirondacks and the Laurentians, and also the question about how connectivity is considered in environmental impact assessment. On urban sprawl, several studies about Montreal and Quebec cities, also connectivity within cities, then a study about Canada, urban sprawl in Canada. Now it doesn't react anymore. Now, yes, now it's reacting too fast. Work about green belts, whether they are efficient in slowing down urban sprawl or reducing urban sprawl, and then one global study about urban sprawl. Some examples. So when you look from Montreal from above, you see a lot of urban sprawl if you pay attention. This is our study about connectivity within cities for green spaces, which has been included in the City Biodiversity Index, also called the Singapore Index on Cities Biodiversity. Then the question about considering within patch connectivity, which is published in Landscape Ecology. The question about how landscape connectivity is considered in environmental impact assessments is actually a special issue that just was completed in the journal Impact Assessment and Project Appraisal, work by our MENV student Charlotte Patterson. This was in the Concordia News 2 weeks ago, if you want to read about that. Then regarding the work along A10, we have lots of photos of cameras taken by animals using structures or not using structures that exist there because there's no mitigation implemented by the Transport Ministry so far at all. So we've done road ecology, mortality research. There's a little video clip that you can watch if you're interested. About Montreal, the change in built-up areas is mind-blowing since 1951. If you see that here, this has been published in Ecological Indicators. How effective are greenbelts? Parnian compared 30 cities with greenbelts with 30 cities without greenbelts and found an effect of greenbelts. That was also in the Concordia News last year. And this is our global study where we see that we have an increase in built-up areas of almost 28 square kilometers per day, which means 1.16 square kilometers per hour. So that's, of course, usually habitat for wildlife that is lost. This is published in PLOS Sustainability and Transformation, which is a new journal just started 2 years ago. That's it. Thank you.
Thank you. Jochen, in fact, Professor Jochen is probably going to do a speaker series somewhere in January on the topic of ecological connectivity and environmental assessment. So stay tuned for more info. And we're going to go to the next speaker. Camilo, it's your turn.
Okay. Well, is it like, could you put full screen? Oh, there it is. Thanks. Yeah, so I'm Camilo. I'm a postdoc at Professor Matthew's lab, and I'm going to talk about briefly about a project that we have that is called Equitable Futures for Nature-Based Solutions. So I'm also part of sustainability in the digital age and future Earth. And specifically, I'll talk about indigenous-led nature-based solutions. So if we want equitable pathways for nature-based solutions, we need to acknowledge the role of indigenous peoples in terms of climate change mitigation and biodiversity. And for that very reason, we are trying to assess the impact of indigenous-led nature-based solutions, specifically the Indigenous Guardians programs and Indigenous Protected Conserved Areas that have been sponsored by the Government of Canada. And we assess that effectiveness by comparing them with other protected areas. So to do that, we have measured carbon stocks dynamics using available biomass, soil organic carbon maps, land cover change, and we have also measured biodiversity in terms of richness, rarity, and other like available indexes that show ecological intactness, all those to build composite index of biodiversity. So with those two measures in mind, what we have found after we controlled for a series of covariates through a quasi-experimental approach, what we have found is that indigenous-led nature-based solutions resemble the effects of protected areas. As you see on top, those that are sponsored by the Government of Canada are comparable in terms of carbon stocks per hectare with protected areas. And that was also the case when we assess this in terms of biodiversity. This indigenous-led nature-based solutions is sponsored by the Government of Canada. They have also a similar effect as compared with protected areas. If we also check those that are not or currently not sponsored by the Government of Canada, you'll see that they also have a similar effect with protected areas, and for that reason are very promising for future finding. And just to finish this piece of results, something that we found is that after this government sponsorship started after 2017, we already found and detected that there have been an increase in avoided land use emissions in those indigenous-led nature-based solutions. So we are already seeing early effects. So what are the take-home messages from this? So first, well, indigenous-led nature-based solutions, those specifically sponsored by the Government of Canada, they have a similar effect as protected areas in terms of climate change mitigation and biodiversity conservation. Second, those indigenous-led nature-based solutions obviously can contribute to Canada's net zero emissions and 30 by 30 targets in terms of biodiversity. And finally, what these results suggest is not only to continue this kind of programs in the areas that they are already happening, but they should expand to other currently unsponsored lands where we could have these potential indigenous-led nature-based solutions. And thank you so much. If you have any questions, that is my email. And we are also looking for interns. I already have an amazing team of interns, but I would love to have more next term. So thank you so much.
Thank you, Camilo. We're going to go to the next and final speaker of this panel, Cristobal. Cristo is a master's in fine arts at Concordia University, and his project is a bit different. It's around art and sustainability, and he's going to show you some amazing pictures of his project.
Thank you, Odile. I just want to say I'm so honored to be next to great scientists and to hear about the wonderful work that you're doing. As an artist, I feel like this kind of responsibility to kind of do science communication and try to do my best to put certain subjects on the table. I just want to try to showcase. Does this make sense? Yeah. I'm going to showcase some images of a project that was premiered in Ars Electronica at the beginning of September. Ars Electronica is one of the biggest festivals in the world of new media. I was really honored to be a participant of that festival. I went thanks to the support of the Ministry of Culture of Chile. My research that I presented there is part of the project that I presented in Leeds, and also part of my thesis with Professor Leila Sujir. This project was heavily influenced by the seminars that I had in Leeds in artificial intelligence, specifically with the use of computer vision to create an understanding of what's happening in the microscope. I would say that I've been working with the technology for the past 8 years. And for this piece, as you can see, what I did is that I hacked a stereoscopic microscope to have robotic components that created what is called a viable system for the organisms. And I don't say viable system in a general meaning, but this is a concept that it was created in the 70s in something called cybernetic management. That is kind of the heart of the concept of this piece. But going to the beginning, I always like to say that I like to work in layers. So I would say like the first layer of this piece is something that you see in this picture. I oppose two images together in these giant projections. So in one screen, I showcase images of drones that kind of imitate the perspective of microscopes. And in the other image, I put a live feed transmission from this stereoscopic microscope that was hacked. So what happened is that along the time that you visit the installation, sometimes you saw relationships between this microscopic and macroscopic world. And at the same time, the microscope have agency to control certain aspects of how the microorganisms were treated. So for this, we created alongside another of the participants of Leeds, Jonathan Wilansky, that he helped me to create some of the computer vision algorithms that kind of give agency to the microscope. And he brilliantly created a way in which we could detect activity in different sectors of the microscope. And then this activity was presented in this computer that was in the back of the room. And we analyzed certain sectors. So sector 1, sector 2, sector 3, sector 4, and we analyzed the amount of activity. And based on that analysis, we kind of imprinted the data into one of the computers so people could see how the organisms were behaving. And this is a direct quote of a project that I was kind of hinting before called the viable system that it was created in the 70s in Chile in what is called Project Cybersyn. This is something that in academia, in art, has been kind of moving around because it was kind of reenacted by a book of MIT professor called Eder Medina in a book called Cybernetic Revolutionaries. And it's basically a study in which how algorithms can be used to control the economy, but using as an inspiration the nervous system of mammals. So in a way, they are creating a way in which we can understand nature in a more non-hierarchical way. That means that I'm done. Okay, sorry. I wanted to put my cell phone because this subject is so huge, and for me sometimes it's hard to kind of grab it. But I just must say to end this that it was amazing to work with Jonathan and kind of create these algorithms to try to transmit and to project certain technologies that are used in climate science to kind of showcase in an aesthetic and philosophical way how technology can help to transmit ideas. Thank you.
Thank you so much, everyone. So I'd like to open the floor to some questions quickly. We only have 3 minutes. So if anyone has a question for any of the panelists, go ahead. Yes, Jen. Someone is bringing a microphone for you.
So thank you all. That was really fascinating. I actually had a question for Professor Jaeger. I was wondering what the net impact of greenbelts was, if you could maybe just speak a little bit, because I found that a really interesting finding. And I just wondered, what the impact is.
Yeah, that's an interesting story. So 90% of those cities that have a greenbelt had actually a reduction in urban sprawl over a time for 8 years. So we would say, yes, overall, they help reduce urban sprawl, not just slow the increase of urban sprawl, but also actually reduce them. So yes, it's supporting all these arguments. We need greenbelts and need to protect the greenbelts in Toronto. You have seen the criminal story that happened there, and Doug Ford now retracted and said, yeah, it's adventurous.
Do we have other questions? Can we check if we have questions online as well? Yes, there is a question.
I have a question for Camilo. For the composite index of biodiversity of Canada, I noticed that the prairies were blue but then like the tundra was green. So where are the biodiversity? Is the blue low biodiversity? Just if you could explain that map a bit more.
Sure. Yeah. Yeah. Great question. So basically this index has 2 pieces. So one in terms of local biodiversity, so richness and rarity. That is one piece, but the other piece is accounting for intactness. So if you have and I didn't make the index. This is the work of, and you could check it. Soto, Navarro, and collaborators in 2020. They published that or proposed that approach. So basically, if you have what you see blue in the prairies is just because the ecological intactness in that area, mostly because of agriculture, is very low. So that would drive the index to low values. And because, yes, if you go to the far north, probably you are not expecting so much richness or rarity, and etc. But the ecological intactness is relatively high. So that's why, yeah. So that's why we are accounting. But we are still having discussions about that. Should we how do we account for both things? But for now, yeah, we're putting both together. Yeah, for this, yeah, just following what was done before. Yeah, thanks.
Thanks. Maybe there's a place for one last question eventually, if there's one. Yeah, we can just move to the next panel discussion. So for this next panel, just wanted to thank all those panelists again. So for the next panel, I'd like to welcome Megan. Megan is joining us online. Faye, Gabriel, and Charlotte to the table. So on this panel, we have Megan Joyce, who is doing her PhD at Concordia University. We have Faye, who is also doing her master's at Concordia University. Then we have Gabriel Tseng, who is a PhD at McGill University. And we have Charlotte, who is a master's at Concordia. So I'd like to pass the word to Megan online. Yeah, Megan, the floor is yours.
Okay. Can you hear me okay?
Yes, we can.
Yeah. Okay. So I just have one slide. I'm working, my supervisor is Dr. Sarah Turner. She's in the geography department as well. I worked on my master's with her and just started my PhD last year. So I'm going into my second year. Some of the pictures I have here from my master's, I'm interested in foraging route decision making. So, and I study Japanese macaques over in Japan. So just to tell you about some of the pictures. So there's a little map in there because I'm from the geography department. You can see that little sort of red marker shows where Awaji Island is. And there's a large population of over 400 monkeys that live on the island. There's a smaller picture above that shows sort of they're provision fed. So back in the 1960s, the Japanese government, in order to facilitate and promote studying primates, they provided funding to start monkey parks. So the Owajishima Monkey Center is one of the monkey parks, and you can see there's deer that naturally range through the area and the monkeys as well. They're wild, so they go up into the mountains and then they just sort of part of their natural trajectory now is to come down and get provision fed from the monkey center, and then they sort of just go about and do their own monkey world things, and we watch them. And so for my master's, what I did was a foraging study. To the right, you can see a series of numbers, the 1, 2, 3, 4, 5, 6. That's just sort of an overhead, like a bird's eye view of a foraging experiment that we did with them. There's a picture sort of to the left top where you can see the little table set up. We put a piece of food on each one, and we're just curious to see how the monkeys are moving through space, to understand how they're making choices and what sort of individual factors might influence these choices. So we looked at their age, we looked at if they're male or female, we looked at their social dominance rank, we looked at if there was competitors. And then what we did is we filmed all of the experiment trials. So we got these really cool pictures of up close and personal. So you can see the bottom bigger one, there's a juvenile monkey, and there's I think it's an adult female sort of running in to try to steal the piece of food. We have one in the bottom center where a deer is picking up food or a monkey's picking up food and there's a deer nearby. And we just looked to see what shapes decision making. We found that the juvies moved really quickly, so they completed the experiment much faster. And then the other sort of significant influence that shaped their decisions was competitors. So if there was an approaching competitor, they often selected longer routes. And then a really sort of, just to finish off, a fun thing we did this summer was we set up at Fourth Space. You can see in the top left-hand corner, there's a picture. We did the foraging experiment with humans. So we set up the same 6 tables in the same shape, and we were curious to see how people are making choices. This has been studied before, but it's often on a computer. So we had a computer version on a touch screen, as well as a physical, like an in-space array set up for humans. So we put chocolate covered raisins out and we observed how people are picking them up. So we want to do a fun interspecies comparison. But yeah, so that's sort of where I'm at and moving. And LIED has been a really great experience. So I hope all of the new LIED people also enjoy it. I'm doing my internship with someone at Future Earth on a sargassum seaweed project. But yeah, that's about it.
Thank you so much, Megan. I'll pass the word to So to Charlotte, let me just put your slides. Okay. Amazing. Thank you, Dan. Thank you, Megan. It's always fun to hear about your monkey research. So I'm working in a paleo-ecological lab. We study past ecological signals. So we're reconstructing a lot of forest covers and moisture signals over the last several thousand years. So I'm working at a particular site in northern Newfoundland. It's about as far north as you can possibly go on the island. You can see my site there just on the map. And it's a very fascinating site because it has a lot of human disturbance over the last about 5,000 years, although most of it is concentrated in the last 2,000 years. And it has a lot of this is indigenous disturbance. And there's a very brief window of Norse Viking disturbance, which everyone loses their mind about. Because it's fascinating as well. So here you can see the bog where we took our samples. We were there for about 5 hours in mud. And then this is a reconstruction of what the Norse houses would have looked like that they built on the site. So just to give you a brief look at the history, this is the Norse expansion into North America. So they made it into Iceland and Greenland in the late 10th century. So they got to Greenland in 985 about from a voyage from Eric the Red. He got exiled from Iceland for murder, I think many murders, and he took his whole family with him. So he landed in Greenland. He set up Bretlahid there. And then his son, Leif Erikson, traveled further west. You can see that yellow line sort of bumping down the coast of what's now Canada. And he eventually gets to L'Anse-aux-Meadows, which is that northern point there on Newfoundland. And he finds grapes. They lose their minds about the grapes and they build some houses because it's a particularly good place for resources. And there's a lot of wood in Newfoundland and there's not a lot of wood in Greenland. So then Carl Svarny, a couple years later, leads a larger expedition there, and they use the same houses that Leif has built, and they stay there for some years, some seasons. It's hard to know how long exactly, but it looks like they were there for, I mean, some of the estimates are from 20 years to 100 years. So it's hard to know exactly. Is that 1 minute? Okay. This is the Norse map of the area. So you can see farthest on the left, that is North America. In terms of indigenous activities at the site, there's quite a bit. That top graph, you can see about 5,050 years ago, there's this maritime archaic, a period of disturbance. Then there's a whole lot in the last 2,000 years, and that tiny little blip is the Norse period. It looks like from the assemblages here that it was used predominantly as a bird gathering and bird hunting site, and also a place where they prepared for moving inland to hunt caribou. So there's a lot of bifaces, which are like the flat stones you can see on the bottom. Oh, I put a picture in. Well done. Okay. And then it looks like it was repeated for warm weather, as a warm weather camp for hunting. And these are some of the birds that they would have hunted. So to do this, we took a lake core sediment. All right, I'm gonna just finish in 30 seconds here. We took a lake core a peat core sediment, and I'm looking at pollen and charcoal. So from the pollen, we're reconstructing, this is a lot of stuff going on here. Just focus on the pretty pictures on the right. That's what pollen looks like under a microscope. The top left is spruce, and then we have alder and sedge. So this is just reconstructing what the land cover would have looked like over the last 6,000 years here. And we're hoping to see any signs of disturbance from the indigenous activities and perhaps from the Norse activities. So yeah, if you want to know more, you can find me because I have a lot more to say.
Thank you. We can jump to Gabriel.
Oh, I have no slides. So. Hi, I'm Gabby. I work at Milo, which is AI Research Institute up in the MILEX. And I work on machine learning technologies for remote sensing. Basically, my big hypothesis is that computer scientists need to be out in the field more. And if they do that, then it'll inform the algorithms they develop in interesting ways. As an example, a lot of remote sensing algorithms in machine learning are developed from computer vision, and in many ways, they don't translate well to actually being deployed in the field. What kind of deployments am I talking about? I do a lot of work in Maui County in Hawaii. Maui is extremely food insecure. It's an island, everything needs to get shipped in, even though they have plenty of arable land. A lot of it gets used to grow, for instance, citrus fruits, which aren't very calorie rich and often get shipped out and also sold elsewhere. And so we do a lot of work with local communities on Maui to try and map what they call canoe crops. So these are crops that were brought over by the original settlers, things like coconut, taro, banana. And there are a lot of challenges in mapping these that are really interesting from a machine learning perspective. It's actually a really difficult problem to extract the spectral signatures of these crops because they're often really inner crops. So within a remote sensing pixel, you could have examples of taro and banana and coconut all together, which makes it quite hard and therefore interesting. And one other thing which working in the field makes real valuable is the understanding of having many stakeholders throughout a project. We've been working in Maui for 18 months, and for the first year, we were just visiting Maui, talking to farmers, talking to the Department of Agriculture there. Maui County is the only county in the US with its own Department of Agriculture, and talking to various stakeholders on the island, just to understand what they wanted and also how we could collect data and build maps for them in a way that really respected their data rights. As an example, all of the data was collected by students. Those students are trained in how to use the data and how to use the maps that we're making. And all of those students live on the islands. So there's a lot of ownership on the islands for the products that we're making for them. So yeah, that's my research. If you have any questions, feel free to ask. I'm happy to talk about either the machine learning side, where there's lots of interesting work to be done at the intersection of remote sensing and machine learning, or on the deployment side, where there's also lots of interesting work to be done. Thank you.
Thank you so much. Faye.
Sort of related to machine learning, but just predictive. I'm working on developing a way to sort of scaffold necessary science communication skills toward collective intelligence for climate change through the use of dialogic education. And one way I want to do that is by using digital technologies like ChatGPT to do that. And so just a little bit of a background about me. I have a background in cognitive science, philosophy, and environmental science. And right now I'm looking into using educational research toward integrating dialogic education with GPTs and using that towards achieving collective intelligence for climate change. And so a lot of conversations regarding climate change, as with lots of contentious topics, come to a lot of challenges, like, for instance, misinformation, disinformation, a lot of political polarization. And so it's very difficult to have conversations like these in the current climate. So how do we get over these challenges? And one way we can do that is by actually providing people the necessary skills to have constructive conversations about these complex topics like climate change. And one way we can do that is through dialogic education. And because everything is becoming more online, like education and communication as well, the knowledge that we have has become more dialogic. If you think about, for instance, how students are learning right now, they're often going on Discord to sort of share knowledge and discuss topics together and get help with homework. And that's been proven to be very instrumental in helping the learning process move forward. And unfortunately, the current mode of knowledge transmission in universities and other institutions have been mostly monologic, which is mostly text-based information where it's just a lot of information being dumped on you. It's mostly a recording of knowledge that we have. So in a way, it's very historical and it's mass-produced and dispersed, and it's assumed to be the ultimate truth oftentimes. But dialogic knowledge is more oral-based. It's orally transmitted through a dialogue and conversation. It's more focused on the present and the future. And the purpose of dialogic is mostly to bring monologic knowledge that we already have in conversation with the present and the future so that we can collectively come up with solutions together to the problems that we're facing, such as climate change. And so my research basically looks at how we can do that, not just in face-to-face communication, but also through digital technologies online, which have been proven to be successful in educational settings and also community settings. And basically that's what I'm looking at. And here, I don't know if it's going to change or not. But there are a lot of case studies that show that this works and that integrating ways, yeah, for instance, like philosophy for children, learning how to think critically, ask questions, engage constructively in conversations about very difficult topics that could often lead to disagreement, as well as Thinking Together, which is an online collaborative learning activity for learning math through a shared space. And research shows that this works because through this shared space, people co-construct knowledge and meaning, and they find solutions together more easily, whether that's in person or online. Learning to Learn Together is another project that has been shown to work through collaborative blogging and reflection. And this gives people the opportunity to sort of take some time to think before they respond. And that way people aren't just reacting. They have time to think and reflect about their thoughts and beliefs before talking with other people. And there's also the eBridges project, where it's an interfaith pen pal activity where people of different religions basically talk together about their beliefs and their culture without any kind of intention to persuade one another necessarily, but to sort of open their perspectives. And basically dialogic is about making people more open to considering other perspectives in order to find solutions. So, yeah.
Thank you very much to all of you. Do we have some questions very quickly from the audience? Yes.
Thanks. For Faye, does dialogic imply technology, or can you have an analog dialogic education?
Yeah, so the reason why I'm looking at more digital technology is because there's ample research showing that it does work in person, in peer-to-peer in-person settings. In classrooms, it's mostly about sort of creating the context from which to think about things. And this can happen in person or online. And we know that it has been working online in a lot of these digital spaces like Discord, like Stack Exchange, a lot of different forums for like basically any kind of support for education. And sort of it would be great to see if you can sort of integrate what we already know works into the online space and sort of recreate the digital landscape in that way.
Do we have another question? Okay. Oh, yeah.
I have a question for Gabriel. Has your research been affected by the fires at all in Maui? And do you have any connection to that or information about that?
Yeah, I was actually in transit to Maui when the fires broke out and the airport shut down. I guess in like the immediate term, yes, because we are no longer a priority. In the like medium to long term, also yes, because we are ever more of a priority. Part of what we're doing is hoping to, working with many stakeholders means the scope of the project broadens a lot. And so, for instance, working with students means that we're hoping to be able to provide opportunities for students to contribute, like for people from Maui to work on Maui without needing to work in tourism or go off island to get jobs. And this becomes like really more pressing because people want to support the island. And so providing these sorts of opportunities is critical. And also like food security is really tied up with like the ecological health of the island. So as an example, we work, there are invasive deer on Maui, a lot of them all over Maui County on the 3 islands that constitute Maui County, and they're really bad for the health of the vegetation. And so this has direct consequences to how flammable the island is pretty much. So yes, in all the medium, long, and short term, but in different ways.
Last question.
Yeah, my question is also for Gabriel. I was wondering if you could briefly talk about how do you include farmers in the process of machine learning? I don't know if they are involved in like when you train images, or like if you could talk about that. Yeah.
Yeah, the first is starting from the data collection. A common thing, well, basically, yeah, the first is in the data collection. So the farmers all consent to this data being collected, and in the process of, and the way that they consent is by accepting to have students come onto the farm. And the students coming onto the farm aren't just there to collect data points, they're also there to interact with the farmers. And as an example, on one of the islands, Lanai, the students were collecting data, but also just learning from the farmers. And it was part of a year-long project that they were doing that they presented to the farmers and to the community at the end of the year. So that's the first thing. And in the process of having, so the farmers engage with the students, they engage with us. We went to visit as many farmers as we could over 2 months on all 3 islands of Maui County. And in that process, they learn about what we can and cannot do with satellite data. They get a chance to really understand deeply like what these maps are going to be able to do. And the third is in the ownership of the data. So this is something we're still working out, but as an example, based on communications with the farmers, we're not open sourcing the maps, which is the typical practice of the organization that I work with. We open source all our methods and all our maps. This is not something we're doing on Maui County because it's been communicated to us that that is not the desired outcome from the perspective of the farmers. And so all through, the farmers are being consulted.
Thank you, Faye, Gabriel, Charlotte, Megan. Thanks a lot. We're going to go to the third and last panel of today. Feel free to. So I'd like to welcome for this last panel, Camille Chabas, Yiza Ginette, Alex Pace, Noah Davide, and then we'll have a video from Frédéric Lavictoire. He's also a LIEN-D trainee, but he was not able to join us today because he's doing his internship at Stuttgart University in Germany. So for today's panel, we have Camille Chabas. She's doing her PhD at Université de Québec à Montréal. Then we also have Alex Pace, who's doing his PhD at Concordia University, Noah Davide, who is doing also her PhD at Concordia University. And yeah, I think we're missing one person, but that's fine.
Sorry, I'm connected online. Sorry.
Oh, okay. Well, yeah, we have Yiza who's connected online. And he's doing his postdoc at Concordia University. So for the first presentation, I'd like to share Frédéric's video. Frédéric is a PhD, a master student at Université de Montréal.
Hello everyone. Bonjour tout le monde. My name is Frédéric Lavictoire. I'm a master's student at University of Montreal. under the supervision of Norma Musso and Olivier Ban. Today, I will present you my current projects in my master's studies in physics. So my first project, which I'm currently writing an article for, is the impact of the car fleet evolution on the energy demand in Quebec. So I did an analysis on the current trends in the light-duty transport sector using a data-centric approach with the Société des assurances automobiles du Québec data. With that, I could estimate the present and future electricity consumption trends for vehicles to gauge the energy and power needed for the fully electrified fleet in Quebec, considering the seasonal pattern and evolving fleet. And I also did a life cycle assessment of greenhouse gases emission, comparing the internal combustion engine vehicles and battery electric vehicles in the context of the province electricity mix. And for some results, we found that the fleet is growing constantly in weight and number. About 70,000 vehicles every year are added to the fleet, which comes to an increase in weight of 11 kilograms, which is a problem since, heavier vehicles are more dangerous also to pedestrians and cyclists, and also more dangerous to lighter vehicles. And heavier vehicles tend to consume more fuel, which leads to higher emissions. We found that the electricity required for a fully electrified fleet is quite enormous, about 125 times more than the current electricity consumption of electric vehicles. But the GHG, the greenhouse gases emission gains, are significant in a way that battery electric vehicles, in the context of Quebec's electricity mix, emit about 10 times less than internal combustion engine vehicles over the same lifetime. My second project, which is still ongoing, is the implementation of a transport system into the merge model. The merge model is a model for evaluating regional and global effects of GHG reduction policies. And as I said, it's still a work in progress, since right now I'm doing sort of a third project, which is the LIED internship. And because of a cooperation between Canada and Germany called H2Clip, I got the chance to, like right now, do my 200-hour internship in Germany, actually. So yeah, I'm working on learning about the model, the German model, which is called New Age. And it aims to, the whole project aims to develop solutions for the integration of hydrogen into transformation pathways towards carbon neutrality in Canada and Germany. So yeah, thank you. I'm looking forward to meeting you all in person in a future event.
So I'd like to give the word maybe to Yiza online. Would you like to share your slide?
Yeah, okay. I actually sent you an email with the slide, so I thought you had received that.
It was a bit too late, sorry.
Oh, okay.
Share them from your screen.
Yes, there's no problem about that.
Thank you.
Okay. Thank you. I am Issa Ginat-Yu, and I'm a postdoc in the Climate Lab, as Odile actually presented. So I have been working on land use and land cover change modeling, as well as assessing the impacts of land use and climate change on wildlife species distribution, focusing mostly on endangered primates and large mammals. And for the past 3 years on my PhD dissertation, as well as in collaboration with the Worldwide Fund Africa program, I actually produced land cover maps for the Congo Basin for the last 30 years, as well as projected future changes under various scenarios of climate change. And in doing this project, I used so many machine learning algorithms, first by using the Google Earth Engine platform with its embedded machine learning algorithms to generate these land cover maps for the current period. and then applying the land change modeler from test sets, from the test set remote sensing software to like produce or project land cover change to the future under various scenarios of climate change. So after coming out with some good results from this project, I found it interesting in continuing this project in my postdoc with a new topic called habitat fragmentation and climate change in the Congo Basin, that is mapping and quantifying effects on single and multi-species distribution and behavioral diversity within Congo Basin landscapes and protected areas. And when I talk of these landscapes and protected areas, you can see them on the map on the right. And yeah, so habitat fragmentation and climate change actually constitute major threats to the world's biodiversity, and thousands of species are declining within several landscapes and protected areas across the globe, with actually worse conditions predicted for the African tropics, especially in the Congo Basin, where rates of deforestation are highly alarming, and the effects of climate change are actually expected to exacerbate these conditions. And as you can see on the map on the right, the Congo Basin is actually covered by over 12 landscapes and 50 protected areas of high conservation importance. And these landscapes and protected areas are highly threatened, and several important issues related to the conservation of biodiversity in these protected areas have like not been fully addressed. So like, for example, even though I have produced those land cover maps for the last 30 years as well as for the future, the extent of habitat fragmentation and connectivity within these landscapes and protected areas have not still been addressed, especially in the scientific literature. And we do not also know how some of these endangered wildlife species are responding to changing fragmentation patterns within these landscapes and protected areas, nor have any baseline information on how climate change is contributing to these problems. And some questions as to what travel routes are species using or will be using to track their preferred climate refugia within these landscapes are still unanswered. We also have limited information on the habitat suitability of many of these endangered species within some of those landscapes and protected areas. And there is also a need to like map the spatial variability in multi-species habitat suitability under current and future climate change and fragmentation conditions in order to like help guide conservation planning within this region. So there's also a good need to identify and map some of the areas of suitable climate refugia for most of those endangered species, as well as identify single and multi-species exposure and resilience patterns to climate change severity. So these are some of the problems that I intend to address in my postdoc, and I hope to present some results in the future, maybe during some other workshops, LIED workshops, or during the summer school. So thank you.
Thank you so much, Lisa. I'd like to give the word now to the next speaker, Camille Chabas.
Backwards. Yeah. Thank you. I'm just coming back from a conference in the United States, and I might have tried to 40 minutes presentation in a 3 minutes presentation, and I might have failed. Feel free to wave and say that I'm speaking too much. So my PhD research is about understanding decision-making mechanism in life cycle assessment models. Life cycle assessment is what we call a decision support model. It's a conceptual model, a mathematical model. It's a lot of models put together to try to identify environmental impacts on a cause-effect chain on an industrial process, for example. to take decision regarding those impacts that we are making, or maybe we will make if we, apply some decisions. So it's about, identifying answers from questions that we're asking ourselves. And it's a modeling technique, it's a modeling discipline, it's a lot of mathematical equations. Life cycle assessment practitioners tend to brag a lot about their models, how mathematical they are, how robust and science-based they are. And it's kind of true, I'm not gonna lie about that. Thing is, like every decision support models are almost entirely subjective. And we don't question ourselves about how we take those decisions when we build the model. How do you choose between two data sets when you can't choose one of them objectively? And you have to make a choice. And when we build those kind of models, we make a lot of choices. And what I try to say to people is, first of all, subjective doesn't mean arbitrary. No one flips a coin in that process. Models are tools. And as such, they are built with an intent, a first intent. I might have completely forgot to, and I'm sorry about that. So they are built like a recipe with a little bit of theory, a little bit of empirical observation, mathematical techniques, and a little bit of narrative, and in a way, assumptions. And it's okay, because that epistemic function, why they are built, is to produce knowledge to support the best decision possible in relation to an initial objective. And here's the first thing. Like I said, subjective isn't arbitrary. Modelers, when they build tools, they're kind of stuck between two very strong objectives. The first is, thank you, Damon. The first is efficiency. You want your model to be efficient. The second is you want to stay faithful to reality as much as you can. And as such, because you try to do the same and to respect your objective, your initial objective, your model is going to build, and it's a partisan approach. So the objective of my research is to understand the decision-making process and to identify why between explicit objective, what the modeler is saying is going to do, and the pragmatic results of the models. Sometimes you have huge gaps between the two, and you have an entire decision-making process there that no one studies and no one talks about, especially in life cycle assessment. We don't look at ourselves. So I tried to make all my results in one slide. And what appears, because I conduct a lot of interviews, I talk to a lot of modelers about their models and the decision they're making and how. And so the results of those conversations tend to put in evidence the network the modelers is working in, and how influences in this network are going to spread in a way, how you are influenced by your colleagues, the stakeholders you're working with, your hierarchies sometimes, how technicalities are going to influence the choices you're making, so the feasibility, the data you have access to, the software you are working with. But one of the biggest influence is the culture. Modelers have huge modeling culture, depending on where they went to school, the country they've been learning their modeling techniques, etc., etc. And I think that's about it.
Thank you so much. Yes, I'd like to pass the word to Alex.
Hey, everybody. I am Alex Patrick. I'm a PhD candidate at Concordia, and I study past environmental conditions in South Central Quebec with tree rings. And basically, the point of it is to give us baseline conditions to understand how the environment has changed over time and give us perspective as to why climate change, or how climate change is affecting an area, by giving us context. And luckily, tree rings are a really important proxy in this field because they record environmental change over time in the thickness and other components of their rings. So what we do is sample usually hundreds of trees, dozens to hundreds of trees to get a representation of growth in a certain area. And then we get a chronology, which is ring width over a certain amount of time. And we'll see the same peaks and troughs in trees all over the same sites. Then we'll go and get, if we're trying to understand climate, we'll go and get, let's say, precipitation records. And we'll see that for the period of overlap for tree ring widths and precipitation records, that there's a lot of consistency and they correlate well. So in that case, we can model that overlapping period, apply it to the rest of the things from before we had instrumental data, and that gives us a model of what the climate in that area is like. But we also have other information, tree rings like fire scars, which if the tree survived a fire, we can see when the exact year the fire happened, because every ring is a year, and we could date those. And so we could also learn about fire ecology and other parts of disturbances based on these tree rings. So what I'm doing is studying 4 different areas. So the yellow areas are part of our Alpine project, and the purple area is a moisture reconstruction. So first I'll start with the Alpine project. You could see a sampling here on one of the second highest mountain in Quebec. And so what we're doing is going to a bunch of alpine areas in Quebec where there's alpine tundra, which is a pretty rare ecosystem in Eastern North America because of how old and eroded the mountains are here. And so it only pops up in certain areas. So we sampled the trees at tree line where the trees are very stressed and there's a relationship between past temperature and the rings. And with that, we can model the past. And it's important for these areas because we don't really understand the impact or the climate history of these areas because there's very little data on past climate. And so this is going to give us insight for these very sensitive areas. Then the other project is trying to create a really long reconstruction because in the alpine areas, trees will only survive maybe max 300 years. But in lower elevations, we have different species, and we're working with cedar trees in the Rimouski area to create a reconstruction of past ecology and also past climate. So what were the moisture conditions? What were the ecological conditions, especially related to fire? Because cedar forests, we have one here, you can see on the left, are very rare. And so we're trying to understand what the fire conditions are and what we found the rings here are actually sensitive to moisture. So how much moisture there was during the season. So we could recreate moisture there. And cedars are the longest living species, which is great because it makes our chronology longer, makes us able to look farther into the past. But also trees along lakes here fall in and are preserved underwater. So we could go really far back into time by interdating the dead trees with live trees and really get an understanding of the past 1,000 or so years, which is great because there was a warming period about 1,000 years ago, and it gives us something to compare the current period to. Thank you.
Thank you. And for the last speaker of this panel discussion, we'll have Noah presenting
All right, so for my PhD, I've been looking at factors impacting abundance and distribution of invasive moths. And we hear a lot about insect invasions. We're constantly seeing the emerald ash borer, hemlock woolly adelgid. The one that I was looking at was the spongy moth, formerly known as the gypsy moth. And this is an invasive infoliator that has been listed by the IUCN as one of the 100 worst invasive species in the world. It's native to Europe and Asia and was introduced to the US and then Canada in the mid to late 1800s. The outbreaks are cyclic, result in very severe impact. So about every 30 years or so, And just for example, we're just coming out of the last outbreak. And these are pictures from 2021, where just in that 1 year, these moths were responsible for over 1.5 million hectares of defoliation in Ontario alone. Now, their preferred host species is known to be the oak tree, but we have observed severe defoliation in many other tree species like maples, conifers, aspen, and others. So these moths, since their introduction, have been spreading westward and northward. This is the female, this is the male. They clearly look very different, but also something important to note is that the female does not fly. So at different stages in their lives, whether the young caterpillars, the older caterpillars, the male, the female, there are a lot of different type of dispersal capabilities. And then we also have this Asian spongy moth variation where the female does fly, and it has been detected in Canada. It has not yet established, but clearly if we look at the suitable habitat in Asia and the comparable habitat in Canada, we are worried about this possibility and looking out for it. So I've conducted a whole bunch of studies at this point, looking at recurring themes, tree species preference, urban versus non-urban forests, above, below snow depth. I'm just going to give an example of one of those studies. I've been conducting those studies all over Quebec. The study I conducted this past summer, I'm curious now that the outbreak is over, if I can predict locations of spongy moth reservoirs, because they're still out there. We just don't know where, and they're in smaller population numbers. So I was looking at a lot of variables, mainly oak presence, but a lot of other variables. And in order to identify my sites, I utilize several softwares. Forêt Ouvert is one of those that gives ministry data, where if we zoom in, there's a layer that gives very specific forest composition. So every species and what percentage of those species are in that forest. I also used databases in QGIS, looking at oak dominant, oak co-dominant, low oak sites. And so I selected 17 patches across Quebec. Each patch is a different color here. I'm just going to zoom in a little bit to this area. And in each of those, I had oak dominant stands, I had oak co-dominant stands and low oak stands. And in each of the stands in June, we put out pheromone traps to attract the males. And in August, we removed those traps. Some of the traps gave us very nice, clean samples, and some of them were in fairly advanced stages of decomposition. But there's a lot of work now counting those moths and analyzing a lot of data from a lot of studies. And that is what I plan to do next, and hopefully have data to provide next time.
Thank you.
Thank you so much, everyone. Would someone like to ask a question to any of the panelists? There's one question at the very front.
The question about the trees and dating back or trying to not predict, but understand what the weather was like. How did you sample your trees? Like you did mention some trees were fallen in the lake, but at the places where you are reaching the critical part of an ecosystem, did you have to cut some?
So we have two different ways to sample. We sample live trees with a borer, which is basically a little hand drill that's hollow in the side, and it gives us just a pencil-like sample of the rings. Okay. So that's what we do for live trees, because we work in parks, and generally we don't want to kill these trees. We're not supposed to in the parks, and we don't want to because they're old growth trees. So we sample live trees with those little samples, and then we find dead trees on the forest floor and sample those with an electric saw. And that way we get a biscuit, a cross section, and we're able to measure it from many different directions, because especially at the top of mountains, they're very stressed and they tend to lean because of the incline and because of high winds. And so there's a lot of wood that's warped as a result of that. So these biscuits are really useful. And then in the lakes, we have scuba gear, and my supervisor scuba dives, gets the samples, brings them out. And then we use a chainsaw once they dry and get cross sections of those. And we have to sample the live samples along the shore of the lake to get a chronology of the live trees, and we connect it to the dead trees after that.
Anyone else?
Yes. Jen and then Jochen.
Thank you so much. My question is for Noah. I was wondering if, this type of research that you're conducting and trying to, be able to predict the location of spongy moths, could that eventually, or, would you like it to eventually contribute to actually efforts to get, eradicate these moths and the impacts that they're having on forests, across North America? So is that sort of a longer term goal of this type of research? Thank you.
Yeah, thank you. So eradication has, in previous outbreaks, it's been proven to be very difficult once the outbreak hits. So really my hope with this last component, because my previous studies were during the outbreak still, but this last component is if we can have some information, especially with climate change, because we're seeing, I have this above and below snow component looking at overwintering survival, and that's going to be changing with climate change. So if we can have some way to predict where the reservoirs are and see an outbreak starting before it comes, then yeah, that would be amazing to kind of head that off before it gets going. Because once it gets going, it's entire forests, and there's not really any effective way to fight against that. Locally, yes, tree by tree, yes, but overall, no. So that's my hope with this predictive study.
We'll take one last question from Jochen.
It's for Alex. I just wonder when it's like look get bigger age and they get smaller.
So just in case somebody didn't hear the question, it's about whether the trees being underwater affects the rings. Well, what's great about them being underwater is that it's low oxygen environment, so they deteriorate much less quickly, and it doesn't actually affect the ring widths. It can affect the chemical components of it, because in the boreal forest there's a lot of iron in the lakes, and so we have to, for certain analyses, we have to destain it and try to remove the iron, for example. But no, luckily it doesn't affect things. So that's why it's such a useful way to go really far in the past. And it's really the only way in Eastern North America that we've gotten past like the lifetime of trees and the dead trees on the forest floor. So past like around 500 years, it's because of this research using lake bed trees. The only thing that does happen is that juvenile dragonflies are in the water and they eat the wood over time. So the oldest samples, most of the deterioration is actually from these insects that are eating it from the outside, but that takes a really long time. So it's not a huge concern, but it does affect how far back some of our samples do go.
Thanks, everyone. Thank you again, Giza, who's with us online, Noah, Alex, Camille, and Frédéric for the video. So I'd like to take a short break. So please have a coffee, have a tea, and then we'll gather back. It's 45, so let's say at 55 for the next activity.
So yeah, take a very, very short break, grab a drink if you need it, step out if you need to. I'd say, maybe in 5 minutes we reconvene. You can bring your drink with you if you would like to. We're going to do a quick networking activity and then some little group discussions to talk about the program and your hopes and aspirations for it. And then there will be lunch afterwards. So yes, take 5 minutes and we'll come back. For those of you on Zoom, you're welcome to either leave or stay as you like. We are going to set up a breakout room. So if you would like to do the small group discussion on Zoom, you are welcome to do so. And I'll leave that to you to decide if you'd like to stick around or not. But thank you for being here regardless.
Thanks, Damon, and thanks everyone on Zoom. Anyone watching on YouTube, we're going to close up the live stream now. Thank you so much. And we will open up the breakout room for people on Zoom. And if you need anything, just let us know. Thanks.